Okay, so here we are in Unity. I've got my 2D project, which is basically recreating a place in New York City. In this case, it is my apartment that I am currently sitting in. Got a ridiculous cat tree over here and everything. So what I'm going to do is go ahead and create a character that is going to be a character that we can actually control around the scene using the arrow keys. So I'm going to go ahead and actually I'm just going to use just one of the basic primitive shapes that I've got sitting around. I don't know what this is doing in my scripts folder. That's weird. But yeah, so I just had like a triangle in my project. I'm going to go ahead and just like resize this. I'm also going to make sure it is in front of everything else. So I'm going to set this order in layer to 20. And I guess I'll set the color of it to like bright pink or something so we can see it a little easier. Okay, so this is going to represent my dog called Roscoe. I'm going to call this Roscoe the dog because he can rename our game objects. And in here, I'm going to go ahead and add a new component. And I'm going to call this new component... I guess I'll call it dog movement. So I'm going to go ahead and name this script. So this is going to be the name of the script. I'm going to press create and add. And as soon as I do that, what's going to happen is Unity has created that script in the default assets project folder. So I'm going to go ahead and move it into my scripts folder just to keep things nice and organized. And then I'm going to go ahead and just open this dog movement script. And as we talked about, so everything in Unity, game objects with components on them. Components tell that game object how to behave. So we are now defining a new component, which is basically a C# script, which we can add as a component to our game object, which is going to tell this game object how to behave and behavior specifically to do with movement. So if we look in this script, so as we know, we have two functions by default. One is called start, one is called update. Start will run once at the very beginning, and then update runs, of course, every frame, right? Every time, like every frame. So that's basically what runs like the game loop. So in start, we'll put anything here that needs to just happen once. In update, however, this is where I want to do things like check if the player is pressing a key. So the behavior I want to aim towards here is with this triangle that is representing my dog. I want this to move according to when we press the arrow keys. So it's going to move in the four cardinal directions, so up, down, left, and right. And so we want that to just map to the up, down, left, and right arrow keys. So if I go back into the script, I want to check for whether the player is pressing down a key currently. So I'm going to use an if statement because I want to check, oh, hey, is there a key being pressed? So I'm going to do input.getKey. Get key. Helps if I can type. And we can see there's actually three different versions of this one function. There's getKey, there's getKey down, and there's getKey up. These actually do slightly different things. So getKey is the one we want because what that does is it will basically it will return true. So this if statement will return true while we're pressing down whatever key it is we're checking for. So the other one, so there's getKey down as well, and there's also getKey up. What those do, so getKey down will only return true on the one frame that you actually press the key down. And then getKey up will only return true on that one instance, on that one frame where you let go of the key. So those are not good for if we want to have the kind of movement where, okay, we're actually moving a unit every time the whole time we're pressing down one of the arrow keys. So getKey is what we want. And Unity has, of course, all of these nice built-in keywords for each of the different keys on the keyboard. So I'm going to do right arrow movement first. So if I'm pressing down the right arrow, if the player is pressing down the right arrow, I want the sprite to move to the right. I'm going to go ahead and just write all the different permutations of this first, actually, before I do anything else, before I actually implement the movement code. This is just the key pressing code. Oops, left arrow. And then else if input.getKey code dot down arrow, and then the final one I'm just going to copy paste, which I'm not actually sure is any faster than going and doing this manually, but I want to change this to up arrow. So down arrow and up arrow. Okay, so if we actually want, let's actually fill in these if statements, this if statement and else if. So if we are pressing the right arrow, what we want to do is move the object 1 unit to the right. So what I'm going to do is, if I just go back to the object, so what that means is I want to grab this transform component and manipulate the position variable that lives on it, the position property. Under the hood, transform is also a script, and it's got a bunch of functions built into that script that we can access as well. So the first thing we want to do, even before we get to that, is we want to get a reference to this transform component. So I'm going to say get component transform, and then I'm going to use this translate function. So what the translate function does is it will basically, instead of directly manipulating the X or Y position, it's telling us, okay, actually take this object and translate its current position by whatever we're defining in here. And what we're defining in here is going to be a vector3, which is, we need to write new vector3. And what this is going to do is let us define an X, Y, and Z variables by which to translate this particular component. So what does that mean? So if I go back to Unity and I click on Roscoe the dog here, so what that means is I want to basically give this values by which to change this X and Y and Z every time we're pressing the key. So I want to move X in the positive X direction, because if you notice, if I select this move tool, if I want this to move this way, X is going up. X is increasing in value. If I want to move up, Y is also increasing in value. So we need to bear that in mind for the values that we put in to move the object by. So in here, because I want to move, when I press the right key, I want to move X in the positive direction. I'm going to write move it 1 unit in the X direction, 0 units in the Y, 0 units in the Z direction. The fact that we have to manipulate the Z value at all, or pretend to manipulate the Z value, is just a throwback to the fact that Unity is still, even though it lets us do cool things with 2D these days, it's still actually a 3D engine in disguise. So it kind of reminds us of that fact when we have to do things like work with a vector3, even though we're working in 2D. I think technically you can actually write a version of this these days. If I go over this, yeah. So if you just give it an X and a Y, it'll just assume that the Z value is 0. But for now, so we can do that, and that's completely fine. For now, just to remind us that we're working with a vector3, i.e. something that needs an X, a Y, and a Z, we will make sure to define all of those values. So I'm going to do the same thing now. I'm going to copy and paste this for moving left, except when we're moving left, we want to move X in the negative direction. And then if we're moving down, we actually don't we don't want to move in the X axis at all. We want to move in the Y axis. And if you'll recall, as we're moving down, if I select this, to move down, we need to increase y by a negative value. So basically we need to decrease y is another way of saying that. So what I'm going to do is put in -1 in here. So we're moving -1 in the y, and then finally what that means is that this again is going to be 0. If we want to move up, we want to move positive y. So I'm going to go ahead and do that and go back to Unity, and we can see it's thinking and doing its thing. And then when I'm ready, I'm going to go back into here and press play. And then, so I'm just pressing the arrow keys right now. So if I press up, it moves up. If I press down, it moves down, left and right. This is very, it's moving very extremely, like moving 1 unit each time is probably way too much. So what I'm going to do is go back and modify a few things about the script. So we're translating by 1 unit in each direction. I'm actually going to multiply this by 0.1. So we only want it to move 1/10 of what it's doing right now. So all of these values, I'm going to go in here and just multiply all of them by 0.1f. So this should work, and if I go back into Unity and play, that should be moving a little more in line with what we would expect. There we go. So that's a lot more reasonable in terms of movement speed as I'm holding down the different keys. I'm just going to modify the script a bit more because I was just wanted to show you the fact that we are manipulating, we're translating the transform in these different axes by defining the Vec2 for them. There are some shortcuts we can take, and there's also some better best practices here. So I'm going to start with this, the fact that so we're defining here each of these Vec2s. There is kind of a shortcut version. If we just want to say, okay, 1 unit positive x, what we can do is write Vec2 dot write. And that is actually a shortcut. As it says here, it's a shorthand for writing Vec2 100, which is what we had before. We can change this one to Vec2 dot left, which is, again, it's a short way of writing Vec2 -1 0 0. Similarly with this, we can say Vec2 dot down, and then with the final one to move up, we can say Vec2 dot up, and that is a shortcut for Vec2 0 1 0, which is what we had. And there are a number of these cool little shortcuts built into Unity. I wanted to sort of, I'm always a fan of showing you the long way around to do it, so that because that actually digs into like what's actually happening under the hood a bit better. But another shortcut you can use is so with get component. This is super important. Get component is going to be something you're going to use probably a lot as you are working in Unity and C#, because ultimately Unity is all about components defining behavior, right? So we always want to make sure that we are able to get access to a component on a game object and use that and manipulate the values, the different properties on that component. So that's why I want you to be in the habit of writing get component like this. But with transform, when we're getting the transform component, because it's a component that lives on like every game object, there's actually a shortcut to get to it. So instead of writing get component transform, we can just write the keyword transform in all lowercase. So I'm just going to change all of these. And then finally, the last thing I'm going to change before I try running this again. So I'm kind of not a fan, and this, you should not get into the habit of writing code this way where you're hard coding numbers everywhere, because this is effectively a speed, right? So this is a variable which we're saying, okay, we're actually manipulating these movement units by this particular value. So I'm going to actually change this so that it is a value called speed. And I'm actually going to define it up here as a global public variable within Unity, within this dog movement script. So I'm going to say public, and it's a float number, right? So I'm going to say float speed, and then I'm going to define the default value of this to 0.1 right up here. But one of the things you'll see that's cool in the moment, I'll show you in a second when I've changed all of these to speed. One of the cool things that will happen is that because we have put this public keyword in front of it, that means that it is a public variable. It's a global, it's a public variable that all of the files and all of the scripts in your particular Unity project can see this. And that includes the Unity editor itself. It can see this particular variable, and the inspector can see it. So what that means is if I wait for this script to finish compiling and loading, we can actually change the speed in here. So we can actually say, so it's defaulted to 0.1. We can change it to another value. So we can say, oh, actually, I want the speed to be even slower. I want it to be 0.01. So if I go ahead and run this, it should run much the same, except that the speed now is even slower. And actually, even while I'm in run mode, I can change this. So I can say, oh, I actually want the speed to be 0.5. And I can go back and test that out, and that's way faster. Just a note, so when I stop playing, you'll notice that the speed has reverted to what I had it set to before I ran the project. So one thing to mind is this is a cool way, exposing all your variables like this in the inspector, you'll find as we go forward is a really cool way to sort of make sure that you're able to tune the game. So you can change things like speed, so you can change things like sizes, whatever it is you need to change in the inspector. But when you stop playing the game, it won't save the value. So if you're like, I tuned the game to find like the perfect speed that I want this thing to move at, make sure that you're noting that down somewhere, because it's not going to change that value. So just a sidebar, you will come across that concept way more. Okay, so that's it for now. So we've got our dog movement script. The next part of what we're going to do is actually change this from this bright pink triangle to actually an animated, to actually a sprite, which is not just a primitive shape, and actually import a sprite sheet and animate that sprite sheet. So when we're moving around, we can see this, this character animate.